Hello everyone. In this video, this is the problem that we will try and solve. The rigid platform below has a negligible mass and rests on two steel bars, each 250 mm long. The center bar is aluminum and 249.9 mm long. Compute compute the stresses in the bars after the center load P equal to 400 kN has been applied. For each steel bar, the area is 1200 mm squared and E is 200 GPa. For the aluminum bar, the area is 2400 mm squared and E is 70 GPa. Okay, so we have here the layout of the problem. The steel, and the aluminum at the center. Then we have the P. Okay. Now, let's try and solve. Okay, solution. The question is, what is the stresses in the bars? What happens is this P will apply a load on this horizontal platform, and that platform will transfer the load to the steel. So this steel will undergo stress. Now if you notice the aluminum, there is a space between the platform and the aluminum. So how will it form a stress if the force or the load will not touch the aluminum bar? Now this is where the deformation will now occur. The steel will deform, so if the steel will deform, the platform will go down. Once it goes down, the load will now be able to touch the platform will now be able to touch the aluminum. And when it touches the aluminum, it will now create stress for the aluminum. So what happens is, if this is the platform, we have P. Of course, the steel will resist as well as the aluminum. So we have the load P equal to 400 kN, while we also have the P of the steel and the aluminum. So summing up forces along the Y or the vertical, assuming going up is positive, we would get 2 times the steel plus the aluminum minus 400 kN is equal to 0. Okay. Now, if you notice, you have two unknowns. We do not have the steel, we don't have the aluminum. The problem also asks for stress. We know that stress is simply P over A. Rearranging, we would get P is equal to stress times the area. So substituting it here, we have 2 times the stress of the steel times the area of the steel plus the stress of the aluminum times the area of the aluminum minus 400. Since we'll now be using areas, and if you notice here in the given we have mm squared, GPa, it's best to set our loads into Newton and mm. So 400 kN, it becomes 400,000 newtons equals 0. Okay, so this is just the same as 400,000 newton. We have the value for the area of the steel, area of the aluminum. We do not have the stress for the steel and the stress for the aluminum. Two unknowns, and we only have this equation. So this is statically indeterminate. This is where the deformation, the equation for the deformation is useful. Now, if this is where the initial location of the platform is, it will deform due to the, the steel will deform due to the load. So if the steel will deform, the platform will go down. Assuming the platform will go down here, then this will now be the deformation of the steel. Okay, initially here it will go down. This is not the deformation of the steel now. If we have the steel over there, okay, while for the aluminum, since the aluminum was initially here, after the platform goes down here, this will be the deformation of the aluminum. Okay, now this vacant space here, this is the 0.1 mm. Now where did the 0.1 0.1 mm come from? This is 250 mm. Okay? This is 249.9 mm. 250, 249, so the excess is 0.1 mm. Now, from the figure, we can see that the deformation of the steel is just equal to the deformation of the aluminum plus 0.1. Steel is equal to 0.1 mm plus the deformation of the aluminum. And we know that deformation is just the stress times the length all over the E, or the modulus of elasticity. So 0.1 plus stress L over E, wherein this is for the steel, 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 aluminum, aluminum, and aluminum. Okay. Substituting the values, we don't have the stress for the steel, but the length of the steel is 250. This is mm. The E is for the steel is 200 GPa. Now GPA 200. Now note that 200 GPa is just equal to 200,000 MPa. Okay, now NPa is actually Newton per mm squared. Okay, MPa is Newton per mm squared. So we'll convert all our units in terms of Newton and mm squared. Okay, so this becomes 200,000 is equal to 0.1 mm plus for the aluminum 249.9 ang length. We also have 70,000. Okay. Simplifying 250 divided by 200,000 divided 200,000, we get 0.00125. 0.00125 stress of the steel 0.1 plus 249.9 divided by 70,000. We get 0.00357. 0.00357 stress of the aluminum. Okay. Now we have two equations, okay, two unknowns. So let's try and solve. Let's substitute this equation to the first one. Let's have it in terms all in. Let's try and solve the stress of steel for this equation. So let's divide the entire equation over here by 0.00125. Okay. Divide the entire equation by 1 over 0.00125. So we only have the stress of steel. Next we have 0.1. 0.0012 divided by 0.00125, 80 plus 0.00357, 0.00125, 0.007 divided by 0.00125, we get 2.856. Okay, substitute this value over here, we'd get 2 times the stress of steel is, we already have 80 plus 2.856 stress of the aluminum. Okay, stress of the aluminum. Okay, 280 plus 2.56 stress of the aluminum times the area of the steel. Okay, area of the steel is 1,200. 1,200 plus the stress in the aluminum times the area of the aluminum is 2,400. 2,400, then we have minus 400,000 equals 0. Okay, we simplify, we distribute 2 times 1, 2 times 80, so we get 2 times 1, 2 times 80, 192,000, 192,000 plus 2 times 1, 2 times 2.856. point. We have 6854.4. 6854.4 stress of the aluminum plus stress of the aluminum times 24 transfer for we have minus 400 equals 0. Okay, combine like terms, so we get transfer the 192 and 400,000 to the other side and combine the aluminum. Have 6854.4 plus 2,400, okay, equals 9254.4. 9254.4 stress of the aluminum equals 400,000 minus 192,000, 208,000. Okay, solving for the stress of the aluminum, we get 208,000 divided by 9254, 54.4. 9254.4, we get 22.5 or 22.48 MPa. Okay, we have the first answer for the aluminum. Solving for the stress in steel, so that would be the answer of the aluminum times the 2.856, okay, then plus 80, we'd get 144.19. So the stress in the steel is 144.19 MPa. We have our two answers for the steel and for the aluminum.